Okay, so let's take a look at the next ones here. And so this one, it asks us what mass of potassium nitrate there is required to prepare 175 milliliters of a 0.35 molar potassium nitrate solution. So basically what we're doing is we're adding, so we can think about a little flask here, volumetric flask, so that's going to be up to 175 mils. We're going to add, some of the powder there, so the right amount, and then we're going to fill it up with water until we get to the total volume. So we're going to calculate what mass we need so that when we get to this 175 milliliter volume, we have the 0.35 molar concentration. Okay, and so what we can do is we can figure out, if we know 175 milliliters of 0.35 molar, we can figure out how many moles of potassium nitrate to add, and by association, what mass that's going to need to be. So to figure out moles again, we have 0.175 liters, so I just converted that milliliters to liters again, times 0.350 molar, which tells us that we are going to need about 0.06125 moles. Okay, and so that 0.06125 moles of potassium nitrate there, we know that 1 mole of potassium nitrate, KNO3, has a mass of 101.11. Okay, and so we're going to need to add about 6.2 grams of the potassium nitrate. Okay, so kind of in a lab, we'd measure out 6.2 grams of potassium nitrate, add it to the flask, and fill it up with distilled water until we get to this point. Okay, let's take a look at the next part. So this is kind of a dilution here, where we already have a solution, but we're adding more water to it. So let's think about what we're changing and what we're not changing. We're going to change the volume, right? Because we're adding 150 milliliters to something that was 325 milliliters. Okay. We're not changing the moles of NaCl that we had there, so that's going to stay the same. Whatever we started with, we're going to end up with, it's just going to have a bigger volume, so by association we're also going to decrease our molarity. Okay, and so there's a couple ways to do this. One way we could figure out in the 150 milliliters how many of this concentration, figure out how many moles there are, so that's going to be the same moles, and divide that by our total volume. Okay, and that's going to work. One thing that's going to help you though, anytime you're doing a dilution problem, whether it's, it doesn't really matter. This equation is also going to help with, we're going to see some reaction stuff, is that we know since molarity is going to be constant in the concentrated solution and the more dilute one, it's going to be the same. And we know that molarity times volume is moles, then we know that the molarity of the first case, so it could be our concentrated, times the volume, of our first case, is going to be equal to the product of our new molarity and our new volume. So we can see from V1 to V2, V2 is going to be bigger, but M2 is going to be smaller, so there's going to be this indirect relationship there. Okay, and so with that, we know our molarity in our first case, 364, times our volume, and this is only for the first solution. So at first we had only 150 milliliters. And you're going to see another thing that works with this is we're not going to have to convert this because we're going to divide milliliters by milliliters. It's the ratio that matters, so we don't have to convert them both. And so we're trying to find the new molarity. So if we were to do that, we can rearrange this equation so that M1 V1 over V2 will tell us our new molarity. Well, then our V2, our volume then, 325 divided by 150, it's going to come out to 475. And when we work that out, you see how this milliliters cancel out. It doesn't matter if it's 150 milliliters divided by 475 or 0.15 divided by 0.475. It's all going to come out to the same, and it comes out to a new molarity of 0.115 molar. Okay, so this M1V1 is equal to M2V2 equation is really going to help with two things: dilutions and some solution stoichiometry where they're going to be reacting.